What is confounding? By the end of this presentation, you should be able to describe and define confounding, assess the impact of confounding and how it can be minimized. Confounding is a form of systematic bias. The word confounding comes from Latin and means to mix up. A useful definition of confounding is a nuisance to be prevented or ruled out. Let's look at an example. We know that age is a risk factor for age-related macular degeneration, or AMD for short. We also know that smoking is a risk factor for AMD. To look at the risk of AMD associated with the exposure smoking, we need to take away the effect of age, as this confounds the association we are looking at. Confounding is concerned with alternative explanations for the association seen between the exposure and outcome. Exposure can be a known or possible risk factor. Outcome can be a disease or condition. We need to remove the influence of a confounding factor in order to get nearer to the truth. We can do this in a couple of ways. Through our choice of study design. Ideally, any confounding is taken care of in the design stage, or by adjusting, also known as controlling, for the confounding factor in the statistical analysis. A major part of epidemiology is establishing associations between exposure and the risk of disease. Confounding occurs when the association between an exposure and a disease is mixed up with the effect of another exposure. This leads to the relationship between the exposure being investigated and the disease being distorted by another hidden factor. Confounding occurs when the effects of two associated exposures have not been separated. The impact of confounding can lead epidemiologists to make an incorrect conclusion that an effect is due to one exposure rather than the other. For a risk factor to be regarded as a confounder, the rules are: it must be associated with the exposure being investigated. It must be independently associated with the disease being investigated. It must not be on the causal pathway. This is a factor that comes on the route from exposure to disease. Let's go back to our example looking at the risk of AMD associated with the exposure smoking. In this example, age would be a confounder because it is independently associated with AMD and it is not on the causal pathway. Therefore, if we want to look at the risk of disease associated with smoking, we have to take away the effect of age. One way we can do this in the design stage is by stratification. In stratification, we compare the risk of AMD in exposed and unexposed study participants of the same age. The other way is to adjust for age in the statistical analysis, for example by carrying out a stratified analysis or multivariable regression modelling. In summary, confounding is a systematic bias that can seriously distort the findings of observational studies. Confounders are independently associated with the outcome being studied, but not on the causal pathway. The effect of a confounder can be minimized in the study design or in the statistical analysis. We must try to control all known potential confounders in studies, although we may not be able to address all of them completely.